transformations, dilations were introduced to you, as well as similarities. So really, like much of Thursday's quiz should be review, because again, this is what I was told. I wasn't here for this, but I was told that this was already introduced to you. A dilation is the only transformation that is not a rigid motion. It is the only transformation that does not preserve size and shape. What are the other three transformations? Rotation, reflection, close, translations, yeah. See, so when you perform any of those, the object that you're transforming doesn't change size or shape. It remains the same. It'll move around and it'll flip and it might turn, but it's not, the size is not going to change. That's not the case with dilation. So there's two types of dilation. We'll just dissect this page here. We don't have to read everything, but there's two types. Is a reduction and an enlargement. Enlargement means get bigger. Reduction means get smaller. When you are performing a dilation, okay, what you're doing is multiplying. You might have been taught before, like, well, when you're doing a translation, what operation are you doing when you're doing a translation? Back before when you did translations. If I wanted to translate an object, what would I do with its points? What operation? Do you know what I mean by operations, right? Add, subtract, multiply, divide. It could be subtract or it could be adding. Translating is adding and subtracting. You get points and you add and subtract. If you reflect, what are you doing? Okay, yeah, you're multiplying by a negative, which causes it to change sign. Same thing on rotation, and it just depends on what coordinates you do it to, would either cause it to reflect or rotate. With a dilation, now you're actually multiplying by a number that's not 1. So if that number is greater than 1, and we call that number the scale factor, the number that you multiply by is known as the scale factor. A scale factor that is greater than 1 is an enlargement. A scale factor that is less than 1 is a reduction. Okay. Enlargement gets bigger, reduction gets smaller. Multiply by a number bigger than 1. So whatever object you have, be it a line segment, a rectangle, a rhombus, whatever it is, gets bigger. If you multiply each point by a number that's less than 1, it gets smaller. Okay. When you ask questions like, is this going to be easy? A lot of that depends on this. The center of dilation. When the center of dilation is the origin, it's a lot less work. All you have to do is just multiply. There's nothing else to do. But when the center of dilation changes, basically what you're doing is not only are you dilating, but you're also translating the object. It's also moving. It adds steps. Not only are you multiplying, but you also have to add or subtract. I do have one example that's like that. Okay. This is all leading towards similarity. Okay. One thing that dilation does do is it does preserve angle measure. So even as your objects are getting larger or shrinking, as long as you're dilating the x-axis by the same scale factor as the y-axis, that's going to preserve your angle measures. Whatever your angles are going to stay the same. And that leads us to tomorrow's lesson. That's why you see the word. So let's knock out the examples. This first question here just wants to know if this is an enlargement or a reduction. What determines whether you have an enlargement or a reduction? Go ahead, Jair. Biggie? What do you call that? Who said it? Okay, Robbie, good skill. And then for the win, so Robbie, what's the scale factor on this one? So is it going to be an enlargement or a reduction? The way you know that, see, you should have been introduced to arrow notation before. Like this should not seem foreign to you. So what this is saying is get a pre-image, get every x and y, and multiply each x and y by 2 because that 2 is greater than 1. Yes, this is an enlargement. Sorry for my handwriting. The difference between pre-image and image, that also should have been taught to you. We use prime notation. Okay, the image here is A, B, C, D. So, I'm sorry, the pre-image is A, B, C, D. The image, which is after the translation, it's hard to see here, but you have these little primes and the little apostrophes. So that's the image. It's like the before and the after. The blue is bigger than the red, so it's an enlargement. Okay, let's do a dilation. We talk about easy or hard. That depends on. And by the way, scratch this off. This was a typo. That should not say yes, sir. No problemo. That should not say rotation. That should say dilation. The center of dilation. So when the center of dilation is the origin, it's a lot quicker because all you have to do is multiply. First, let's write this in arrow notation. Arrow notation says, okay, we're going to get every x and y. And then they want us to apply a scale factor of 1/2. So what type of a dilation is going to be? It is going to be a reduction. And then all I would write is 1/2 x and then 1/2 y. Sarabi did say this is a reduction. How can you determine it is going to be how did you determine that it was a reduction? I haven't actually dilated anything. The scale factor. The scale factor. Yeah. The scale factor is less than that. Let's actually go and apply this though. So let's see what. Let's go alphabetical order. Start with J. So J prime. J is currently at what is that? -3, 0. So then I would have to just then get -3 times 1/2 and 0 times 1/2. What is -3 times 1/2? -1.5. So J prime is going to be at -1.5. 0 times anything is 0. Let's look at K prime. K is currently at 0,3. So this brand new K is going to be at 0 times 1/2 and 3 times 1/2, which is 0,1.5. Normally I prefer to do improper fractions, but since coordinates are a type of measurement, that's why I put the decimal there, 1.5. And then finally, L prime. L is currently at 2, -2. So we're starting at 2, -2. Actually, you know what? I should probably take the prime off the original. This should just be J. This should just be K. That's before the transformation. This should just be L. So then 2 times 1/2 and then -2 times 1/2. So we got 1, -1. Did I go too fast? Does anybody have any questions so far? So now when I finally go and graph this, how should this look compared to the triangle that's there already? It should look smaller. Specifically, how much smaller? Half the size. Let's see if that's the case. -1.5 and 0 is halfway between the first box and the second box on the first line and the second line on the x-axis, one to the left. 0, 1/2 is the same thing but going up. And then 1, -1. One to the right and one down. When I connect the dots, it's obviously smaller because those lines should be parallel. The sides should be parallel, but I hand drew it, so that's why it doesn't look perfect. It's not bother me. questions there? Is anybody gonna claim that they haven't seen this before? No? Last teacher didn't cover this? Yeah, these are the ones that require a little more work. You might not need to do this on the quiz. I actually want to lean towards you're not going to have to do this on the quiz, but it's just a good review of dilations. Here's a rectangle, and we want to dilate the rectangle using a scale factor of 5. Doesn't be big, doesn't be an enlargement. But the center of dilation is not the origin. So the way that I've taught this before, I don't know if you remember something called SRA. Did they teach it to you like that before? When your center is not the origin, SRA stands for subtract, rule, and then add. This also applies for rotations. As rotations and dilations are the two that occur around the point. Reflections occur around the line, an axis of reflection, but rotations and dilations occur around the point, right? So when they tell you subtract, rule, and add, the add and subtract apply to the center. I'm talking about the center there. The rule has to do with the dilation, or even better yet, let's do it this way, so you can remember better. Instead of dilation, let's call it the scale factor. That's when you apply the scale factor. So far we got 4 points. W, X, Y, Z. Let's just go in alphabetical order. Let's start off with W. W starts off at -4, -1. Let's apply these rules. What are we gonna do first? What are we gonna do first? Subtract. What are we gonna subtract? The center of dilation, which is at -4, -1. Okay, so let's see. W prime. We start off with a -4 for X, but because that's this negative, not this -4 here. That's this -4 right here. Oh wow. So our center of dilation is going to be the so that's it actually in the. No, it's not. Okay. The center of dilation just happens to be the exact same thing as one of the vertices. Well, what's the first thing we're supposed to do? We're supposed to subtract that. What's minus a negative? Addition. So I'm gonna. So -4 plus 4. And then the y that I'm starting off at is -1. But then I'm supposed to subtract the -1, so that's +1. What do I end up with after the S part of SRA? What is -4 plus 4? 0. Let's just go ahead and because it's not going to fit on the page. Let's just go ahead and like as I'm actually doing the subtraction, let's actually go ahead and start putting the rule in. What's the scale factor here? 5. So whatever I get from the subtraction, I'm going to already start multiplying it by 5. What's -1 plus 1? 0. And let's go times 5. Also. So now I just did the rule part. I just multiplied by the scale factor. But what's anything times 0? 0. 1? Any number times 0 is 0. So I have the 0, and then I have to add back the center. Adding a -4 is the same as subtracting. Adding a -1 is the same as subtracting also. So when all is said and done, that first point never changed. That first point is going to stay the same. W. Yeah.
Wait, when you say adding and subtracting, how can you do that?
because they happen to both be negatives, happens to be that the centers are negative. What is adding a negative the same as? What is adding a negative the same as? What is subtracting a negative the same as? I actually am subtracting what I'm supposed to subtract. I actually am adding what I'm supposed to add. It's just the fact that I'm adding and subtracting negatives. So it looks different. I'll do one more, and then I'll give you guys a chance to do the last two. So let's do x. X is starting off at negative 5, 2. So now let's see x prime. We start off at negative 5. The first thing we want to do is subtract the center. What is the x of the center? Negative 4 minus a negative 4 is the same as plus 4. The y starts off at 2. I'm supposed to subtract the center. What's the y of the center? Negative 1. Plus 1. So for my x's, I end up with negative 1. I'll go ahead and apply the scale factor now, so that's times 5. And then here I get 3 times 5. So for the x's, I end up with with a negative 5. But then I have to now add the center back. So it'll be negative 5 minus 4. Three times 5 is 15, and then minus 1. Oh, that's going to be good. This would be negative 9. And then finally at the end, when I add back the center, actually, no, I'm already done. I did it already. Okay, that's the last step. Negative 9 and then 14. Why don't you guys do the y? Let me know. Y is starting off at 1, 4. Raise your hand when you have it. Let me know where you're going to end up at. What is the image of the y? Where is the y going to end up at? Penny, do you know? You can ask Aziz as well. What'd you get, Charisma? I did it in my head. That's not what I got. Hey, what'd you get? Honesty? I might be wrong. I did it in my head. So if I end up being wrong, I'll give it to you. But that's not what I got. That's what I got. So I'll just do it on the board, and if we got the same thing, then I'll give it to you. And that's what I got in my head. Let's see. He said 21, 24. So let's go y prime. We start off with a 1. The first thing you do is subtract the center. The center happens to be at negative 1, negative 4. Minus a negative happens to be plus, so 1 plus 4. For the y, we start off at a 4. Minus a negative happens to be a plus. So it ends up that in both of them, after the first part, we end up at 5 and 5, right? But now we're supposed to get that 5 and 5 and also multiply it times 5, because that's the scale factor. That's the rule, yeah. But that's the scale factor. Scale factor of 5. That's the R part rule. That's the rule. And then the last part is to add the center, but when you're adding a negative, that's the same as subtracting. So here we would get 25 minus 4, and then we would get 25 minus 1. So y prime ends up being at 21. One more. Z starts off at 2, 1. You guys do that one. You already finished, Hattie? Oh, give somebody else a chance. Down. Got it? Where'd you get it? So what, 26.9? Maybe that, wait, hold on. You might be right. No, she might be right. Hold on. I'm trying to do it in my head. Yeah, actually, I think you're right. Swedish fish? You like Swedish fish? No? Okay, so we got 2 minus negative 4 is 2 plus 4. 1 plus 1 because it's 1 minus negative 1. So we got 6, then times 5, and then 2 times 5. So finally it ends up being 30 minus 4, and then 10 minus 1. 26. I'm not going to graph it because it wouldn't fit on that graph anyways. The more important thing is finding the points. Any questions there? Trying to get to these. No? Did I go too fast? All right. For this one here, all I really care about, the reason why I put the example here is just to find the center of dilation, because the scale factor here would require the use of distance formula. We don't need to get into distance formula right now, but I wanted to show you when they give you an image and a pre-image, how do you find the scale factor? Easiest way to do it, connect the dots. If you connect all the images with the pre-images, they should meet somewhere. Where they meet, that's the center of dilation. So I have a line tool. You would use a straight edge. We have a ruler, some type of a straight edge. So I connect A with A prime. And this one here doesn't tell me which one is the image and which one is the pre-image, but frankly, it doesn't really matter. Connect C with C, connect B with B. And even though it's not perfect, it does appear that they end up meeting. It looks to be at 3, negative 2. 3, negative 2. My line tool is a little bit off. You could probably be even more precise with your pencil because you have a finer tip than I do. I don't think this will be on the quiz on Thursday either. I'll go back and look at it, but this is more just because we were also supposed to use this as a review of what you did before. This should have been more what you did before during transformations. Now, what is going to be on the test on the quiz on Thursday is more as it relates to similarity. So that's these examples. I'll try to get as many of them in the next 5 minutes or so, and then whatever we don't finish today, I'll continue tomorrow. So a circle in a photocopier has an enlargement. A circle in a photocopier enlargement has a 6-inch diameter. If the enlargement percentage was 125, what is the diameter of the pre-image? So we're going backwards. We're going from image to pre-image. So if the photocopier made the circle bigger, originally the circle was smaller. So what should I do with that 125%? Divide it. Now, but we're not going to divide by 125. We're going to divide by 1.25. When we turn the percentage into a decimal, we move it 2 to the left. Is that 4? I think it should give me 4, right? 4 inches. 6 divided by, or no, I'm doing that wrong. It's 4 point something. 4.8? Exactly, or is that rounded to 4.8? 4.8 against 4.8. Yeah, that's fine. I can, if I start by 8, I'm good, so I can do a couple more minutes. A reduction of the same pre-image as a circle above has a diameter of 3.6. What percentage was used for the reduction? So they want to know the scale factor. So the pre-image was 4.8 because this is the same pre-image. A reduction of the same pre-image circle has a diameter . So, all right. So if this is a reduction, right, and we ended up at 3.6, what did we start off at? What was the pre-image on the one above? You know, forget about the 125. That was a scale factor. But as far as the diameter goes, what was the diameter at the beginning of the last one that we did? No, that was the after. Remember, I got enlarged. Yeah, that's what we found, 4.8. So, if you were going to now get that 4.8 and reduce it down to 3.6, it would be 3.6 divided by 4.8. That should be 0.75. Right? Did I get that right? 75. It should be 75%. 75% reduction. The a reduction is getting smaller, right? So as a fraction, if something's gonna get smaller, the smaller number should be on top. It should be a proper fraction. So yeah, I have to read it a couple times just to make sure I got the wording right. But it says a reduction of the same pre-image. Up here, they gave us the image originally, which is the 6. They gave us the after, and we found the before. So what they're saying is get this before, but now reduce it down to 3.6, and then give me the percentage, give me the scale factor. So, okay, so then that would be 3.6 over 4.8. There was a 75% reduction. Let me do one more, because if I can do one more, then I can fly through the rest of them tomorrow, because they're all pretty much the same. So how does this apply to triangles, right? If now this doesn't necessarily have to be a mid-segment. I know we talked about mid-segment, but mid-segment would only be if like point A and point B were in the middle of their respective sides. So this, we're not talking about mid-segment, but if you have these parallel sides here in a triangle, these triangles are similar, what are called similar. We'll talk more about similarity tomorrow. Okay, similar means that a dilation can be applied in order to go from one to the other. So here they want to find C. So what we're going to assume is that the original triangle is the smaller one, is this BOA is the smaller one. That's the original. So are we enlarging or are we reducing here? Yeah, we should be enlarging. And they want to know what C is. This is the important thing. If one of the points is the origin, there's a lot less work that has to be done. All I have to do here is a proportion. Okay. A proportion means that you can, I'm going to write an equal sign with one fraction on each side. One of those fractions is going to be the scale factor. Get the scale factor from the side where they give you both points. So like here, they're giving me all the points I need, right? Which coordinate is not changing? The 0. So I'm going to ignore that. Well, which coordinate is the 0? The x, yeah, the x is not changing. I'm gonna pay attention to the y. You could put well, like I see. So okay, if you're doing an enlargement, then put the bigger one on top, I guess. So put the 6 on top, put the 4 on the bottom. When they ask you for scale factor, just reduce that. What is 6 over 4? 3 over 2. You don't have to reduce it up there, but you'll get the same answer. But at least if they ask you for scale factor, reduce it. But then when they want to know C, say, all right, if you look at the other side, which coordinate is not changing? Which is the y. The y is not changing, so I want to put the x's. Is the 6, though, part of the small triangle or the big triangle? No, this 6 is part of the smaller triangle, so I want to line it up with the smaller triangle. Here on the first one, I did big triangle over small. So I got to do the same thing over there, so now I'm going to put the 6 even where the smaller triangle was. What goes on top? The C that I'm looking for. Now, because the C is along the bottom and the x wasn't, the y wasn't changing, I know that the second coordinate already is going to be 0 because it's on the x-axis. What I'm looking for is what the x is going to be. So cross multiply. That's how you solve the proportion. 4c is equal to 6 times 6, which is 36. Divided by 4. So c is going to be at 90. The only problems I have left for tomorrow are going to be just like this. You can get through them pretty quick. Any other questions? All right, so let's go ahead and put this away, clear with that. Pencil, paper, calculator.